Good afternoon, everyone, and welcome once again to ECA's Technical Tuesdays webinar series. My name is Omar, I'm the Communications Manager here at ECA, and with us today, as your presenter, we have the wonderful Darren Crannis, our Technical Manager, on camera now. Darren will be talking about PNB, Protective Neutral Bonding, I believe that stands for, and all about that. We have lots of materials already available for ECA members. We have a slightly more in-depth guidance note that's available on the members area of the website. We have a YouTube video describing PNB earthing in a little bit more detail as well. That's available on the ECA YouTube channel. As you may know, PNB is a big part of the proposed changes in Amendment 4 to BS 7671. So we also have a video mentioning that, as well as other changes that could appear in Amendment 4. Again, that's on our YouTube channel and also available via the ECA website. So to learn a bit more about Amendment 4, do check out our channel on the website. To ask questions today, we'll be looking at Q&As at the end of the session. You should have a question mark button in your browser now. Feel free to make use of that at any point during today's presentation, and we will get round to as many questions as we can at the end of the webinar. That's enough from me. Over to you, Darren.
Thank you ever so much, Omar. That's a great rundown, and welcome everybody to this Technical Tuesday. It's one of many. We have a lot of these on catch up as well for our members. You can come into our members only area and look at our previous videos, but for today, we're going to talk about what we call a new earthing system that's been proposed for 18th edition Amendment 4 DPC. I say a new earthing system, or is it? So welcome to today's presentation on PNB. Just an introduction, my name's Darren Crannis. I'm a technical manager here at the ECA. I've been involved with sort of data centres, earthing and bonding, sort of large supplies for sort of 10, 12 years of my life. My sort of background was in telco and earthing and bonding. And so it's a great pleasure today to talk to you about PNB and the developments of PNB and earthing systems in general. So we'll look at general earthing systems and requirements for bonding, so we can lead into sort of what PNB is. We'll explore what PNB is, go into a bit more detail and show you some practical examples which you'll probably recognise that you've seen many times before. We'll wrap that up with a summary, and as Omar has said, very welcome for a Q&A at the end. So what is all this about? It is not pink neutral bonding that's been floated around, it's protective neutral bonding, and actually it's been a sort of staple of our earthing system in the UK for decades. It predates the ECA G12 G4 in 2013. In fact, it probably predates right the way through to the 60s. It's usually found where a transformer supplies a single consumer. Those working on large supplies, which are, sort of a half MVA, 1 MVA, 2 MVA plus transformer, would have seen this many times before with a little link inside the either the spill box or the first point on the network, so usually the panel board. We do consider this TNS for earthing and bonding purposes. Again, this isn't new, but it's been newly recognised by BS 7671, so we'll come on to that shortly. But before that, let's just have a little refresh. So TT systems, you'll see this diagram here. It's straight from it's part 3 or part 1 of 7671. So a TT system only has one point directly earthed at the source. All the exposed conductive parts of the installation are connected to earth electrode independently of the supply, which is known as the source earth. So all exposed conductive parts within the installation are connected to an earth electrode, which is electrically independent to the source electrode. And you can see that here. And we have separate neutral and protective conductors throughout the system on that one. So this is our sort of TT systems here. Moving on to our what we call our TN family. So TM systems have one point directly earthed at the source, so the source earth at the transformer. So all the exposed conductive parts of the installations are being connected to that point by protective conductors. With TNS, systems have a separate neutral and protective conductors throughout the system. The protective conductor, PE, is usually the metallic covering of the cable supplying the installations, or a separate conductor. All exposed conductive parts of the installation are connected to this protective conductor via the main earthing terminal of the installation. So we do still see a lot of TNS about. Predominantly it's the old lead sheathed cables, more of a rarity now. Typically you don't see this on new developments unless it's, for example, high-rise flats because of the threat of diverted neutral currents. So you don't see a lot of TNS installs or brand new TNS installs these days. Most of our network is made up of what we call PME. So this is what I call the second so far of our TN earthing systems, or our TN family. So with TNS PNE, the neutral and protective functions are combined to a single conductor. We often refer to this as the PEN in part of the system. So this type of distribution is also known as protective multiple earthing, PME. And you can see there are additional source electrodes along the run. So the supply system PEN conductor is earthed at 2 or more points, and that's a really important note before we come on to PNB. And an earth electrode may be necessarily at or near a consumer's installation. All exposed conductive parts of an installation are connected to the PEN conductor via the main earthing terminal and the neutral terminal, these terminals being linked together. So probably 80–90% of our network is now made up of PME, and you'll see that the neutral and earth combined right up to the premises, and then it's split typically at the supply head. Let's quickly recap bonding too, and especially in the case where main protective bonding conductors are connected to the MET. For PME systems, it may reduce sort of touch voltages in the event of an open PEN. It does serve a function of minimizing magnitudes of touch voltages when a fault occurs. Like we say, protective main bonding is required in most electrical installations. It's an essential part to ensure we get rapid disconnection supply, so we know that as ADS, automatic connection to supply, and it's required in each consumer that all extraneous conductive parts liable to introduce a dangerous potential shall be connected to the MET. So nothing new there. Okay. The conductive part is likely to induce a potential, generally earth potential, and not forming part of the electrical installation. So typically they are incoming services, metallic sort of pipe work or services entering the building, including, for example, telecommunication buildings. Other services as heat pumps, other supplies, all follow the same sort of principle. Is it a conductive part liable to introduce potential, generally earth potential? We've got a great Technical Tuesday webinar on earthing and bonding, which we've done previously up in the year, which you can look back on YouTube. Generally with this, because we're talking predominantly now a sort of more PME, so TNCS systems, anything with a PME supply, generally more onerous throughout the whole standard. So if we look at BS 7671 and look throughout, we will see more onerous and arduous conditions where PME conditions apply. And that's something we see a lot. We're going to summarize this right at the end, but where PME conditions apply is probably written about 12 or 14 times throughout the standard. Generally, PME requires larger bonding conductors because of the thermal effects in the event of perhaps a loss of neutral. So they can be up to 50 millimeters in diameter, unless the DNO specifies otherwise. So they may actually be much larger. And other PME conditions apply for remote buildings. So any remote buildings on a PME network have to have their extraneous conductive parts required bonding all the way back to the MET. So there's a lot of green and yellow here. So for TNS type systems, we're up to 25 mil, the same for TT. For PME systems, we're up to that 50 mil when we need to run that out to our outbuildings as well, if they've got extraneous conductive parts. So we're using a lot of copper here for PME networks. It really does sort of wrap us up nicely onto what is PNB. So the best way, obviously, is a new system diagram. So this is taken from Amendment 4 of the 18th edition draft for public comment. So we say another variant of TN, so part of our TN family, is TNCS PNB, and it's not new. PNB is a TNCS system, but it is not PME. It's a variant of TNCS, and it's confined to cases where low voltage connections are made at just 1 point. So remember with PME we spoke about earlier, it had to be 2 points or more for the connection to earth. This is only made at 1 point on the distribution network, and it's either commonly at the dedicated transformer for a single customer connection, or in locations rurally where pole mounted transformers are installed, typically again for a single customer connection, but not always, and we'll come on to that. The low voltage neutral conductor is connected to an earth electrode at a point remote from the transformer, usually between the transformer and the supply terminals of the consumer. This connection should be made as close as practically possible to the consumer supply terminals in order to minimize the voltage rise in the event of a broken neutral. Normally with PNB, it's a bolted connection and sort of skilled and supervised, so either in a panel board or it's on a pole mounted transformer. It's not likely to be lost. Sort of whole issues with PME at the open pen aren't associated with PNB, because it would have to be a malicious act to remove that electrode. So PNB may be adopted if the number of consumers is 4 or less and the distance from the connection to earth is 40 meters or less. So this comes from the ENA, the Energy Network Association's guidance. If we look at the diagram on your screen now, okay, the electrode in the diagram is not what we call it's not an earth electrode as you think, like a rod or a conduit disc or something like that. We're just indicating here the connection to earth, and we're going to come on to that a bit later on. Importantly, where this connection is made to the source, PME conditions do not apply, and that has its advantage, which we're going to go on to later on. A quick sort of triangle here. How does PNB compare to PME? Not all TNCS systems are PME, but all PME systems are TNCS. So under the sort of TNCS banner, we have PME for protective multiple earthing, where there could be 2 or more connections to the earth electrode, where PNB only has that 1. So PNB refers to protective neutral bonding, and it is a method of earthing. It's similar to PME, but again, the connection is installed either adjacent to or at the consumer's installation. Talk about PNB as TNCS, but it's not PME. The PNB variant of TNCS is confined to cases where the low voltage connections are made at just 1 point. And we mentioned this before, that there might be several points for PME. So the easiest thing to remember with PNB is the connection to the electrode. So the neutral earth is only done at one place. How does this look like on a diagram? So for those of you who have access to the IET guidance note 8, this is a pictorial diagram from GN8, so you can see where this connection is made. Again, it's made sort of at or near the consumer's installation, and it's only done once. You'll see that the source electrode there only is made once, and it's not multiple times. So you can see between the supply here and the installation, and we thank the IET for the use of this image. We'll move now on to how this looks like in reality. So the source of this is from the national grid, so formerly Western Power Distribution, and this is looking at protective neutral bonding. So we've got a couple of applications here on how this is made. Note where the LV electrode has been positioned. It's only once and it may not be at the source transformer. So it's particularly common in rural locations where an LV connection is made at just one point on the network, typically where a pole-mounted transformer is dedicated to a single customer connection. It's also used on some large connections that have a dedicated substation. In these situations, the substation's buried LV earth electrode is installed at one point on the network. This type of earthing is typically considered the TNS, but is classified as TNCS because of the combined neutral earth element of this. And this is in the engineering recommendation G12 of the ENA. So importantly here is it is a TNCS system, but it's considered TNS for earthing and bonding, which has its advantages, which we'll speak about later on. Again, how this looks like in reality, you may see a small pole mounted transformer. So there's a 11 kVA to 400 volt transformer here, and that would serve typically 4 homes or 4 connections, and they would have to be a maximum of 40 meters away from that electrode to minimize any sort of potential risk of an open pen. This would still be PNB. The supply heads would say PNB on them. So this is very rare, but you may come across it. Again, if you do not, do not treat every pole-mounted transformer like it's PNB, it will be labelled at the supply head. Again, what this looks like in reality, and we thank Wilson Power Systems and Pandalco for supplying these images. More commonly in our networks, we normally associate PNB, technical neutral bonding, with single site transformers. So we've got a transformer here. This goes through to a panel board. Inside that panel board, you'll see an example here of a couple of neutral earth links. So we call that a neutral earth link. Very common if you run generators, you'll see the same thing. It's where we make that connection. And this is where our electrode is. We've made that one point of connection. They're a boltable link unless it's under sort of skilled and controlled areas. Unless it's malicious, you're not going to lose your connection to earth. So I'll leave that slide on a minute there. You'll probably sort of look at these and go, you know, we've been installing these since the 60s and this is how we've done it. This is not a new thing, but it is a new thing for our standard. So what benefits does this have? Importantly, where that link in the previous slide is installed in the consumer's installation, PME conditions no longer apply. Okay, this is unlikely for DNO supplied installations such as pole mounted transformers. However, if the transformer is dedicated for that one consumer, then it's highly likely that PME conditions will not apply. Where this has advantages now, if we look at the extract from table 5.1 from guidance note 8, we can see that the maximum bonding conductor sizes are now no greater than 25 mil. Before they had to go up to 50 millimeters squared, now down to 25. So where PME conditions do not apply, your bonding conductors become much smaller. Also, when you've got non-PME conditions, you can bond any extraneous part in remote buildings in line with regulation 544.1.1. So you can just bond them locally according to their supply main. Again, this regulation 544.1.1 applies to non-PME installations. So effectively, we can just treat PNB like TNS when it comes to earthing and bonding. And that makes our lives a lot easier, saves on a lot of resource, a lot of copper, and a lot of more arduous conditions that we're going to go into later on just go away. So again, to summarize, we talk about conditions where it's not PME. So again, we're bonding up to 25 millimeters for TNS and TT systems. Just to highlight there that outbuildings now become even easier to deal with. we can bond those in accordance to the incoming cable protective conductor. So that means those outbuildings now will have a bonded conductor between 6mm and 25mm. Okay, the days of sort of 50mm bonding conductors go when you come to TNS conditions. Again, this is only relevant to non-PME conditions. That includes TT, TNS, and PNB. So it's extremely useful. Other advantages, well, we talked about PME can be onerous, especially if you look through Part 7, which modifies the general parts of the British standard. So Section 7 of special locations, that becomes much easier and probably much cheaper, okay? Because a lot of the references, which, because we've got ESQCR requirements, they go away when we introduce PMB. So ESQCR requirements are there, especially for PME. That does state that PME shall not be used. So in 702, there's a note there about earth mats or electrodes, 20 ohms or less. That's removed because these are not PME conditions anymore. Construction sites, so the requirements for fault protection, again, the 704.411.3.1, they go away. Agriculture and horticultural, they have special requirements where PME applies. PME no longer applies. Caravan and camping parks, okay, again, they have references to ESQCR, they do not permit PME connections. The same with marinas, exhibition shows and stands, mobile transportable units, even 722, so EV chargers. So the use of, should we call it a unicorn device or the open pen device, if you have a PNB network, which is considered TNS, PME conditions no longer apply. So you don't need any sort of unicorn device, any open pen device there, because your risk of your open neutral are practically zero. And that's cost saving for the customer. Onshore units and offshore units and sort of temporary installations. So again, once PME conditions do not apply, our lives as designers and installers in Section 7 becomes a lot easier. So what can we do for you on this? Luckily, we have a comprehensive guidance note, so that's downloadable for all our members, and we talk about when is TNCS PME and when is it. So it's a very similar sort of feel to the sort of presentation. There is the ENA, the Energy Network Association, G12 version 5. That goes into a lot more detail about PMB and PME networks. The IT Guidance Note 8 on earthing and bonding is a great addition to anyone's toolbox. So generally you normally have your regs books, your BS 7671, maybe your on-site guide, generally GN3, and I often think that GN8 should be the fourth book in your selection. And give the read to sort of BS 7671 18th edition amendment for DPC. So we do go into this in a bit more detail. We have a YouTube video on this on our YouTube website as well. That comes onto our YouTube channel. So we have a lot of content on our YouTube channel. That's at youtube.com/ECA Live. That includes our amendment for DPC video, where we sort of take about an hour to run through the major changes, including PMB and any other changes that are proposed to the standard. We've also got videos on bond or not to bond, including our bond of commercial kitchens, and we have a data sheet on that. So these Technical Tuesdays tend to sort of follow on from a theme and link to each other. For our members here today, you can always call our technical helpline, so details are on there. So that's on 0207 313 4833. That's 0207 313 4833, and that is manned by a technical manager from 9 till 5 every day, 5 days a week, or email us at technical@eca.co.uk. Other benefits for our members as well as our free technical helpline, we have our business support, we have our contracts and commercial, we have our ERAMs, we also have our eComs, so our new software for sort of following the EAS for competency. discount on British standards, so almost 100 British standards for a very small price every year. And again, you know, we're really working for our members to sort of lobby, represent. That includes all our sort of work on the JPAL committees to ensure that sort of the next version of the British standard that you all use is the best it can be and easy to use. So mopping all this up, PNB is a form of TNCS. Very importantly, and this is the bit that we can't emphasize enough, it's not PME. Bonding requirements are often TNS and they're more favourable, and Section 7 becomes a lot easier and probably a lot cheaper for your clients as well, because the PME requirements just simply go away. We're getting towards the end of the webinar now, so to reward you with your sort of efforts, you can download a CPD certificate. So I'm going to leave this QR code on the screen for a few minutes. So if you zap the QR code with your phone, it'll take you through to a feedback form, and also to you can gain your CPD certificate. And Omar's back on the screen now, which means we can handle any questions.
Thank you very much, Darren. Really excellent presentation, as always, very thorough. We had a question from the audience. They then said that you've answered their question during your presentation, but I'm wondering if perhaps it's worth revisiting anyway, just for the benefit of the wider audience. So the question was, where TNCS is not allowed as a supply, I assume this is because of PME. Does that mean PNB TNCS systems would be allowed?
So yeah, to summarise on that one, we came to that later on in the presentation, is nowhere in the standard do we say that TNCS cannot be used. The standard says PME cannot be used. So where it says PME cannot be used, yes, you can use PNB.
Great, thanks, Darren. And as Darren mentioned, lots more resources on the ECA website, on the members area, in the technical page of the website, and our YouTube channel as well. Lots of our YouTube channel videos are now present on the ECA website as well, so you can find them there too. So that concludes today's session. Darren, I don't know if you wanted to add any more information, any more contact details, but you had the technical helpline up there on screen. That's available exclusively to ECA members. Oh, we've just had another question come in. Let's just address that one before we wrap up for today. So this person asks, if 4 houses are on a pole-mounted transformer, is this PME?
No, the DNO will give you those conditions. Generally, it's rare in rural, but the DNO, the network operator, will tell you upon inquiry, or they will write it on the supply head if it's PMB or PME. So by inquiry, under ESQCR, they must tell you what earthing arrangement you got. More common on a dedicated substation for, just say, a factory or a large commercial building. It is found rurally, but don't assume it's PMB just because you see a pole-mounted transformer and one house. Ask the DNO and they will clarify what earthing arrangement you got.
Okay, thanks, Darren. So I'm just going to check for any more questions. We have one more that's come in. So kind of alluding to what you just mentioned, Darren. Question says, so we assume that we will only know if it's PNB by a label on the DNO cutout. Is that correct?
For smaller rural supplies, absolutely yes, and they are rare. And I have seen these. Unfortunately, I have a picture of one to show you today. I have seen this once or twice. When it comes to the larger supplies, again by inquiry. So yes, if it is a PNB connection, the DNO will tell you.
Okay, thanks, Darren. We're going to wrap up today's session there. Our next Technical Tuesday session is on the 1st of October, Tuesday the 1st of October at 12 p.m. once again. It will be on emergency lighting with ECA Technical Manager Chris Edwards. So do join us then. We look forward to seeing you then, to answering any questions you have on the 1st of October. Thank you again, Darren, and to everyone for joining us today, and have a great rest of your afternoon.
Thank you, everyone. Thank you, everyone.